I have only one fundamental basic question. This question will define the rest of the interview. I understand, Sophia. What's the question? Savinder, tell me in 2 sentences, if you want to deliver your software better, faster, cheaper, DevOps is the thing to do, and I am your person to do it. We will talk about fundamental questions like this. What the heck is DevOps? What is not DevOps? Why is scaling DevOps so hard? Hello girls and boys, how's it going? Come here. I'll tell you a very interesting story today. So when I was interviewing for my remote job, I'd done about 5 or 6 rounds I think, and some of these were very intense rounds, some of them going even over 2 hours. Lot of technology discussion, lot of brain power thinking. And after all of that, I got a call from the HR one evening. They said, hey, you've done well so far. Now is the final round. And it's with the lady, let's call her Sophia. Sophia is head of business. Sophia is the person who's, funding this entire transformation program, of which DevOps is one part. Because by then I had established a good relationship with the HR. I asked her, tell me a little bit about Sophia. And she was like, Savinder, honestly, this is gonna be a make or break interview. We've heard good things so far, but if Sophia doesn't like you, then we have a problem. So I said, all right, that's fine. Let's go for it. And so the interview began, right? And after the basic introduction, Sophia straight away jumps in. She says, hey, Savinder, I've had a look at your resume. I've studied your feedback in detail. I've spoken to everybody who's interviewed you. I have only one fundamental basic question to start with. And she said, this question will define the rest of the interview. I understand, Sophia. What's the question? And she goes, Savinder, tell me in 2 sentences, what the heck is this DevOps and why the F should I care about it to put my money on this thing? This is exactly how I was asked the question. And imagine, put yourself in my shoes and my thoughts then. It's your dream job that you're talking about. The salary is bloody awesome and you're expecting one of the most complicated questions on planet Earth. And this is the question you get asked. I took about 1 or 2 seconds to regain my balance and I said, Sophia, with all due respect, I do not need 2 sentences to answer this question. All I need is 3 words. Better, faster, cheaper. And I paused and I said, Sophia, if you want to deliver your software better, faster, cheaper, DevOps is the thing to do, and I am your person to do it. I took a pause again, and Sophia smiled. And that evening, girls and boys, I had my offer letter. So this is the story of how I got my remote job and the last interview. In this video, we will talk about fundamental questions like this. What the heck is DevOps? What is not DevOps? Why is scaling DevOps so hard? We'll talk about these kind of things. If you're new here, my name is Savinder Puri and I've been in this build, release, DevOps, cloud, software engineering field for over 2 decades. I'm currently Associate VP, DevSecOps and SRE at a major SI system integrator. I'm based in India. You can go check my LinkedIn profile for more details. Let's get started. So when you hear the word DevOps, one of the first thing that comes to your mind is CI/CD, continuous integration, continuous delivery. Let's talk about it and understand this in very simple terms. What is continuous integration? What is continuous delivery? And then we'll build up after that. Right? Let's go. What is continuous integration? So imagine a team of developers. They are building a software and they are all writing different parts of the software. Let's say different parts of the functionality of a software. When each of them code their software, they put it into a version control. Now, version control could be anything like a Git, a GitHub, Azure DevOps, anything like that. So code getting into version control. And then what happens is you have a CI server which is listening into this. And what does this do? This is continuous integration happening here. The CI server listens to a check-in done on the source control creates a build, and then that build is distributed across multiple delivery agents. Now this build could build artifacts, could be a jar file, a war file, a binary file, some config, something like that. And each of these get distributed into an app server, a web server, a DB server. Now I've taken a very simplistic example and you can complicate it as much as you like. But basically, continuous integration is where your code is continually integrated by your version control system and a build is created. That's continuous integration. And then the delivery of that build into a environment, the first environment, is called continuous delivery. Now let's go further. Now, in the olden days, when the software was simple, it was just one app server, one DB server, one web server. And as life got complicated, as software grew more complicated, you wanted to have 5 application server, 10 web servers, 20 database servers. Because the size of the application increased, the number of people accessing that application grew into hundreds, thousands, millions, you needed more infrastructure. What happened as a result of that is, instead of one box, now let's say you had 10 application servers created. Now you had to create these 10 application servers by hand. You had to install the software by hand, install the OS by hand, install all prerequisites by hand, and so on and so forth. Now, when that started happening, that is the time when the likes of Chef, Puppet, and Ansible came about. And they said, hey, why you're doing all of this by hand? Let us automate that. So that is when infrastructure as code started getting formed, and you could write a piece of code which would at that time log in into your ESX server, the VMware ESX server, and create 10 machines which you would declare as an application server. Right? Now, this changed when the cloud came about and they said, hey, instead of creating on VMware, let's go create on AWS, let's go create on Azure, let's go create on GCP. But that's the fundamentals of infrastructure automation, where you have some automated scripts which can grow and create infrastructure on the cloud. Now, when then this got more complex, that is the time when containers came about. And to give you a loose example, if you have, let us say, a retail website, if you have let's say you're selling water bottles, right? Now on this website, you do not need very, very high-end graphics. You do not need huge complex sound system. So you don't need the full operating system on each of these machines to be able to render a simple website. So what you do, you strip down whatever is required and then you start creating containers. What's a container? Think of it like a Ziploc pouch. Think of it like a Ziploc pouch. It has a bunch of stuff. It has the prerequisite software, Windows operating system. It has my ability to deploy my war file. It has Tomcat, and all of that is put together in a Ziploc pouch. This is a container. When I give you a container, you can take this and then put it on your machine, and it has everything that is required for that piece of software to run. So that's where the concept of containers came about. That is where the Docker, the Amazon ECS, container service, Redshift, all of that started. Now, as you went into containers, instead of putting everything on one container, you started spinning up 10, 20, 50 containers. And then there was a need to maintain those containers. How do you figure out what container is running what? Out of my 100 containers, 2 containers went down. I need a control plane for that. And that's where container management came about. I don't have to say, go and deploy my application on this container. Kubernetes or a Swarm or a Mesos would automatically take care of it. And it will tell me if some containers are down, some are up, some are reaching thresholds in terms of memory, RAM, disk space, all of that stuff. So that is container management. But you still had to specify your container range, where your container system is located. You still had to do all of that. And that's when the cloud guys came about and say, hey, why should you care on where your container is running? Give us all that headache also. And that's where serverless came about, where they said, why do you care where your servers are running? You write a code, a piece of code, a Lambda function, and let me figure out where to run the Lambda. You should not be worried where this Lambda function is executed. Tell me the horsepower it needs and I will go and execute and get you the results. So it is serverless, not because it is running without a server, but you don't have direct access to the server. You don't even need to know those details. Those are all abstracted out. All you say is for this Lambda function to work, these are the levels of hardware that I required. And Amazon goes ahead and figures out the hardware and runs it and gives you the output. That's serverless. And then another revolution started where they said, hey, you want to run a banking software? It's amazing. Why do you care about running the software? We will run the banking software as Mambu, as a SaaS service. And you give us the input, we'll give you the output. Don't worry about where software is running, how it is running. That is where the era of SaaS came about. You don't have to set up, let's say, a Salesforce on your server, right? Salesforce is running somewhere. You get access to the cloud. You get access to your instance of Salesforce. You know for sure your data is protected, isolated from everybody else, and you can access your area as you want. That's where the SaaS came about. This is the evolution of software engineering in general, DevOps, cloud, everything in one slide. Hope this makes sense. Now let's go ahead and talk about Agile. So how do you go? What is the relationship between Agile and CI/CD? You have a new sprint and you're doing Agile development, maybe you're doing some backlog. You have this list of things that you want to do in your backlog. From the backlog, you create a sprint. Sprint is, these are the 2 things I will do in the next 2 weeks, right? You pick that up, you create a new sprint, then you write the code for that. That code goes into version control, picked up by the CI system, a build created. Remember the previous diagram? This part, the first 2 parts, the build created, continuous integration starts. What does that mean? You do the build, you do the unit test, you do the sanity testing, code quality, all of that. And then that goes into a repository manager. From there on, your continuous testing starts, your functionality testing starts, all of that starts happening. And then you go into continuous delivery, where you deploy into one environment, the second environment, the infrastructure as code creates the environments, and then the code is deployed there. So that's how Agile and DevOps, CI and CD merge together. Now the next question. Why is scaling DevOps so hard, right? And why do DevOps engineers, why are they in so much demand? Have you seen this? If you've not seen this, I would highly recommend you to Google the periodic table of DevOps tools. Look at this. So let me take you through this a little bit. What is continuous integration? This gray kind of thing. Hang on, let me get the point. Yeah, this continuous integration is this grayish color. So this grayish color is here. So Jenkins, Azure DevOps, GitLab, Travis CI, Circle CD, Maven, Bamboo, Gradle, AWS Code Build. All of these are continuous integration tool in this grayish kind of thing, right? Then you go to this blue, security, OWASP, Digital.ai, App Protect, then SonarQube's Nexus, Aqua Security, or Checkmarks, HashiCorp Vault. All of these are security related. So it tells you the size and the scope of DevOps tools. Now, obviously, this is not the only tooling in DevOps. There's a lot more. This is another continuous delivery map. So if you look at continuous integration here, this is developed by Atomic. Similar thing, this blue line, if you follow, it will give you all the tools on continuous delivery. Now, this is a very famous picture. You would have probably already seen it. It is actual enterprise architecture of Amazon.com and Netflix. If you zoom onto these pictures, these are actual services running and their correlation, connectivity with each other, their dependencies and so on and so forth. You can Google these pictures and then you can blow in, zoom in and you will find all of this. This is called the infamous Death Star microservice architecture. It's an old picture, but it's a fun picture to show. So today's enterprise extends data center all the way up to the cloud. That's where the complexities are. Also, the teams are also diversely created You can hear about things like the platform team, the something as a service team, the facilitating team. This picture is taken from a book called Team Topologies. If you've not heard of that book and if you're at the leadership level, highly recommend you go read that book. It'll tell you a lot about how, what are the ways in which these DevOps teams are being structured today. This is a famous DevSecOps reference architecture created by Sonatype. It talks about the entire SDLC and what all tools can be integrated into the SDLC and what are the functionalities that each of these tools has. The reason of putting this up is to tell you the complexity of DevOps in a large enterprise in 2024. Alright, so let's talk about scaling DevOps and why the heck is scaling DevOps so hard, right? So first is implementing Agile at scale. For an organization to be able to adopt DevOps at scale across business units, across groups, across teams and across geographies, a prerequisite to that is to be able to operate at Agile at scale. Now, at scale Agile doesn't mean safe. It means that all the teams who are involved in the DevOps cycle should be able to operate in an Agile way. Why is that important? Because when Agile comes, you get sprints, you get user stories, you get stuff which has to be delivered every 2 weeks. That gets into source control, that picks up CI system and all of that stuff, right? So that's why Agile and DevOps go together. And the fundamental requirement is institution and the adoption of Agile at scale. What's the next one? Maybe you'll have some new roles and responsibilities created. Maybe you'll need an environment manager because so many environments are getting created now and you need somebody to manage all the environments and the deployments happening. You need a way to figure out what the heck is deployed where and why is it deployed. You may need a DevRel, a developer relation, because your organization is creating content which is consumed by dependent startups or other organizations. You're exposing APIs, so DevRels come in there. You might need a community builder because you've created communities and maybe you open source a part of your product, so you need community help there. So that's another dimension to scaling DevOps. This is very important. You might to deconstruct the organization silos. Your development team, your testing team, your support team, your DBAs, all of this could be sitting in different silos. They need to be brought together so that they can work together and deliver a product and be responsible for the product delivery. That means these guys could be reporting to different people. All of that has to somehow align. The reporting structures have to align. The silos have to be broken. The organization has to be reconstructed in some shape or form. You have to institutionalize new ways of working across the enterprise. People might not be used to doing a release every 2 weeks, 3 weeks. For example, if you go to some of the telcos these days, they're still doing a quarterly or a 6-monthly release cycle. There, if you have to adopt DevOps, it's a lot of change in mentality, way of thinking, and doing things in a very different way. Upskilling workforce. Now this is very important. You would think this is obvious because why would people not want to upskill themselves? You'll be surprised. This is where the maximum challenges come because people don't want to upskill. They are comfortable in their environment. They are thinking, jo chal raha hai chalne do yaar. They don't realize that their job itself is at stake because it is being automated by somebody else. So it comes with acceptance of the situation. So that's scaling DevOps. Another factor is reworking the vendor relationship. So in a large enterprise, there are definitely different vendors which work with you. And some maybe a vendor is doing testing, another vendor is doing mobile development, another vendor is doing the support. So all of these guys have to align together if you have to deliver better, faster, cheaper. Measuring the right metrics from a business and a technology standpoint. What does it mean? Figuring out what to measure and then figuring out how to measure it within your context. Because measurement is a big thing. What you measure gets improved. Lots of communication upstream for the senior exec management and downstream for the workforce at large. Driving changes through a mix of consensus and directive. Because there will be times in the DevOps transformation journey where only consensus will not work. You will have to say, guys, this is how we are going to do it from Monday morning, my way or the highway. And a lot more based on the current maturity of the enterprise. This is why scaling DevOps is a tough problem. Hope this video made sense. I've tried to break down some very complex topics into very simple terminologies. Let me know what you like best about this video. Let me also know if you want me to create a video on what are the DevOps career path, how it spans out. I have a dedicated series on how do you crack DevOps jobs, how do you create a resume. I'll pin it in the comments. You can also look it up on my channel, and I'll see you in the next one.